everyone. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. And yeah, today I want to talk to you about a couple of standards for building event-driven applications. These slides on my talk, they're already on speaker deck. So if you want to grab them, they're here. And the demos I'm going to show, they're already on GitHub. And I'll share the links at the end of the presentation too. So if everything I show you today, they will be available to you at the end of the presentation. And if you want to ask me questions after today, this is my Twitter. So feel free to follow me and ask me questions there if you wish. Okay. All right. So let's do a little bit of introduction. And let's imagine we are building an event-driven architecture. And let's again imagine that we are building an order processing system. So, it's a shopping website or something like that where users, put some orders and you want to handle those orders. So in that scenario, you typically have multiple services doing different parts of the order processing. But let's just keep it simple and just work with 4 services. So maybe you have a front end getting the orders. This is typically a web application running on App Engine on Google Cloud. Then maybe you have a payment processor service. This is running on Cloud Run, which is a container service on Google Cloud. Then maybe you have a shipper that deals with shipping, and it's a cloud function because it's simple enough that you can just do it in a function. And then maybe you have a notification service where you notify the user about the order, the progress of the order. And since this is event-driven, these services, they don't know about each other. They don't call each other directly. They don't depend on each other. What they do is they do their own part of the order processing. And once they're done, they will just emit a message. So for example, the front end will receive the request from the user. Then it will do its part. And then it will send an order received message. This message will go to a message broker or an event bus. That's kind of the backbone of your event-driven architecture. Then the event bus will figure out that this message type is registered for payment processor. So the payment processor will get that message. It will do its part, the payment processing, and then it will signal to the rest of the system that the payment is processed with another message type. And then this continues, right? But the key thing here is that these services are totally independent. It's easy to add a new service. It's easy to remove another service because they kind of don't depend on each other. They just receive messages they're interested in, and they emit messages once they're done with their part. That's what event-driven is, right? Now, in this event-driven architecture, you need to decide and communicate a couple of things. First, you need to decide on the envelope of the events. So every event has 2 parts. First, the envelope. And the envelope, by envelope, I mean the information that you use to route the message. So you need to decide on that information so that your system knows how to route the message, what information to use to route the message. Now, the other part of the event is the data, the payload of the event. But envelope is especially important because that's what you use to route the event. So you need to decide on that. And secondly, you also need to decide which service publishes or subscribes to what events, right? Because some services, they only receive events. Some services, they only publish events. And most services, they both receive and publish events, right? So it would be nice, and actually I would say it's actually essential, not nice, but essential, that you kind of decide on this and also communicate so that people who want to consume the events from your services, or the people who want to talk to your services, they know how to reach to your service, what kind of messages to send, or what kind of messages to expect from your service. So the summary of my talk is basically CloudEvents, they define an envelope for events that you can use, and we'll take a closer look on that next. And AsyncAPI, it helps you to document the event formats that you're sending, and it also helps you to document which service publishes or subscribes to what events. So basically, I'm proposing that take a look at CloudEvents, take a look at the Async API, because they already help you with these problems that you need to deal with anyway. So now let's look into CloudEvents first. Well, first of all, why CloudEvents? Why should we even care about this technology? And let's go back to our event-driven architecture. So in event-driven architectures, at the very high level, what you have is that you have event sources sending some messages, and these messages, they end up with some event destinations, right? That's what happens at the high level. Of course, there are things in the middleware, that does this routing of messages using some information that you decide, but it also does more. It probably does some filtering of messages. Maybe you want to enhance some messages. So this middleware is not just routing, but it's usually more complicated than routing. It's filtering, enhancement of events, things like that. And also in today's world, you don't have one type of event source working in one type of event medium. You typically have multiple different kinds of event systems. So maybe your event source is sending a message to a Kafka topic. Maybe another event source is an IoT kind of event source. So it's using MQTT protocol to send its events. And maybe another event source is it's a cloud service that's sending messages to a Google Cloud PubSub topic, something like that, right? So in this scenario, your middleware ends up being quite complicated, because now it needs to understand different protocols like Kafka, MQTT, Google Cloud PubSub. It needs to understand different formats. Maybe you're using JSON, which is typically the case, but maybe you want to use something more efficient like protobuf or Avro. You have event schemas for these different event types and event formats. So you probably want to communicate those. So all of a sudden, your middleware, the way it reads the events and the way it routes events becomes quite complicated, because you're dealing with multiple formats. Now, CloudEvents, it's an open source specification for describing events in a common way. So that's the key part of CloudEvents. It gives you a common format that you can use for all sorts of different eventing mediums, let's say. But it's not only specification, it's also SDKs to read and write CloudEvents. So you actually have code you can use to kind of read and write these events. It defines a minimal set of context attributes, and these attributes are used to route the event. So that's kind of the envelope of the event. And it also has this notion of data, or data base64, where you can put any kind of payload for your application, basically. So how does a CloudEvent look like? Well, there are two modes of CloudEvents. One is called binary mode, and the other one is structured mode. So let's look at the binary mode first. So here I'm sending a CloudEvent, just using curl, just pure HTTP. And one thing you realize is these special headers. So I'm sending some special CE- headers, and these are CloudEvent headers. Now, first, the content type defines what mode you are working with. So the content type application JSON specifies that this is a binary mode CloudEvent. Then you have some required CloudEvent headers. So the spec version, the version of the CloudEvent, in this case 1.0, the type of the event, the source of the event, and the unique ID of the event, right? The minimal, basically minimal information you need to route the event. Then there's some optional ones, the time and subject of the event if you wish to use. There are some extension attributes. These are special headers you can add for your own application in case your application needs extra information to route your event, right? So these are basically custom to your application. And then finally, the body of your request, it's the actual payload. In this case, it's just a simple JSON, right? So this is the binary format, binary mode of CloudEvent, where the CloudEvent is basically in the headers. And this is good for receivers who might not understand CloudEvents. If you're a receiver and you don't know how to read CloudEvents, it's usually okay, because in binary mode, these are in the headers. The CloudEvent information is in the headers, and you can just ignore them. You don't have to read all the headers, right? So that's what binary mode is good for. Now, the second mode of CloudEvent is called structured mode. And in structured mode, everything is in the body. So the same event that we looked at. Now, when you look at it in structured mode, you'll realize that first, the content type is different. So the content type is CloudEvents JSON. So this determines that this is a structured mode CloudEvent. Then the body has everything. So the spec version type and source and ID is there. Then you have the time and the subject. Then you have the extension attributes that you can add if you wish. And finally, the data, the payload lives under the data field of the body. So the difference here is that instead of using headers for CloudEvent information, you're using the body for everything. And structured mode is good for use cases where maybe you have multiple hops along the way, so your event has to go through multiple routers. And having everything in the body kind of helps for that, because maybe the router doesn't understand the CloudEvent headers, and if it doesn't understand, it might drop your event. Whereas if you have everything in the body, then typically routers don't touch the body or look at the body of events. But either way, binary mode or structured mode, they do the same thing. And when you use CloudEvent SDKs, you can read them in either way. So it's basically up to you which mode you want to use. Now, CloudEvent gives us the format, but it also gives us different formats. So you can use JSON by default, but you can use more efficient protobuf, Avro, and even XML if you wish. You can decide how you send the event over the wire. So by default, it's HTTP. But if you're using AMQP, Kafka, or others, there's different protocols. Basically, they're called bindings that you can use. There's a lot of SDKs in different languages for reading and writing CloudEvents. And you also have CloudEvent libraries from different vendors. Because the CloudEvent envelope, you would use CloudEvent SDK to read that. But then for the body, it's the vendor-specific body, right? Like the body of the event is basically typically what you're trying to get. Like, let's say on Google Cloud, maybe you're reading the storage events. So the body will have the storage events, and you would use that library to read that. And actually, I have this repo. This is not in C#, it's actually in .NET, but it's very similar. So I'll just show you quickly what this looks like. So for example, here, I'm using the CloudEvents SDK, and I'm using the Google Cloud storage library. And then the way this works is that we receive an HTTP post request. We create a formatter with the storage object data, which is from the Google Cloud storage library. And then we read the CloudEvent from the HTTP request. So this gives us the envelope, and we print that out, the ID, source type. But then the data has already strongly typed storage object data. And this gives us the actual Google Cloud storage event. So the Google Cloud storage event wrapped into a CloudEvent. If you are Java, which I think you are in this conference, Java SDK has a lot of different samples depending on what you use, like Spring or Quarkus and just basic HTTP. But the idea here is the same, right? Like, so if you look at the basic HTTP one, for example, you use the CloudEvent SDK, and then the CloudEvent in Java, there's the message reader and message writer to read and write CloudEvents. So basically, from the message reader, you just get the CloudEvent, and then you can use Google Cloud's Java library to actually read the body if you wish. Here, I don't do that, but you could do that. But this gives you a quick idea on how these SDKs work. All right, but you need to be aware that in CloudEvents, there's a batch mode where you can send multiple events, but they're not supported in all protocol and SDK combinations. And just to give you an example, JavaScript SDK supports HTTP and Kafka batch mode, but it doesn't support MQTT batch mode. Not all event formats are supported in each SDK. Again, JavaScript SDK supports JSON, but not others. And not all protocol bindings are supported in each SDK either. So JavaScript SDK supports HTTP and Kafka, but it doesn't support the rest that I mentioned here. So the point is that there's a lot of different combinations you can use in CloudEvents with batch modes and event formats and protocol bindings and languages. But not all the combinations are actually working or supported. So you need to check before you want to use whatever features you want to use. That's the point of this slide. All right, and then finally, there's 3 specs coming up in CloudEvents: Discovery API, Subscription API, and Schema Registry. These are all about the life cycle of events. So how do you discover events? How do you subscribe to different events? And how do you see the schema of these events? So we'll see how CloudEvents evolve beyond just event formats. And it's also interesting because the next spec I'm going to talk about, AsyncAPI, also does things with schemas and subscriptions and things like that. So I think it will be interesting to see how CloudEvents evolve along with AsyncAPI. All right. So as I mentioned, in event-driven architectures, you need to decide and communicate on the envelope. And I feel like CloudEvents give you that envelope for whatever protocol language combination you want to do. So my suggestion is take a look and use it if you can. And there's actually good industry support for it as well. Adobe I/O uses CloudEvents. Google Cloud uses CloudEvents for EventArc. I know Azure Event Grid, they use CloudEvents as well. So it's also becoming not just an open source project, but also an industry standard when it comes to events. And the more people support CloudEvents, then it will be easier to communicate between different systems because at least there's a format that you can rely on, right? Now, the next thing that we need to tackle is this, service. Which service publishes what events and how do I subscribe to them and what can I send to these services? So for that, we have AsyncAPI. So let's just take a look at that next. Okay. So what is AsyncAPI? AsyncAPI, it's another open source specification, and it's to define asynchronous or event-driven APIs, basically. You're probably familiar with OpenAPI, which is for REST-based APIs, and it's been around for a while. So if you are familiar with OpenAPI, it's the same thing, except it's for asynchronous APIs. And just like CloudEvents, it's not just it's not just specification, but rather tools to visualize and validate these definitions, and also generators to generate code from these definitions in various languages. So it's not just specification, but also like an ecosystem around that. And we'll take a look at some examples of this as well. Now, there are some main concepts in AsyncAPI. I try to list the top ones. So at the top level, you define your AsyncAPI application. So that's basically your top level application. Then underneath, you define how do you talk to that application, and you do that via a server and a channel and a protocol. So the server defines the main, basically the main protocol that you can use to talk to the application. Then the channel has basically different ways of talking to that server. For example, if you are using Google Cloud PubSub, the channel would be different topics, right? So the server is the PubSub service, but the channel would be different topics under that service. And the protocol will be set for your server because, if you're talking to PubSub, the protocol will be Google Cloud PubSub protocol, but it will depend on what kind of server you're using. So once you have these basic things in place, then you can have producers or publishers and consumers or subscribers to send and receive messages. And you also define your messages and what your messages look like, what their format look like, and what you can expect to send or receive. So these are the basics, and then once you have those, then there's also bindings. There's bindings for everything, like for server, channel, operation, and message. And these bindings, they allow Async API to extend to different vendors. So each vendor, like Kafka or Google Cloud PubSub or others, they will use these bindings to add their own custom things. And we'll look at the examples of this as well. So these are the main concepts. And if you are coming from OpenAPI world, you might be wondering, what is the difference between OpenAPI and Async API? And actually, there's a really good link that I'll share with you that does this in a good way. So if you look at OpenAPI, you define your application under info, and you do the same with Async API. Then you define your server and security. So that's also the same in Async API. But I think the main difference between OpenAPI and Async API is it's what you define to get to. So in OpenAPI, you define paths. It's path-driven, right? So you define paths, and the path has operations on them. And these operations are HTTP operations, right? Like get, put, post, things like that. And then the operations that you can have, they have requests and responses, because everything is HTTP driven in REST, right? So that's why you have operations and paths and requests and responses on those paths. Whereas in Async API, you don't have paths, you have channels, okay? That's the basic unit you talk to. But within channels, you have two operations, either publish or subscribe operations. And then what do you publish and subscribe? You publish and subscribe messages. So instead of requests and responses, you have messages with headers and payloads that you exchange. And then later, you define how your message looks like and what this schema should be, just like you define how your responses and requests should look like in OpenAPI. So it's very similar in that sense, except the concepts are slightly different. Instead of paths, you have channels. Instead of HTTP operations, you have async operations like publish and subscribe. Those are the main differences. Now, this is the simplest async API definition. So we define our application. So that's the top level application we're defining. Then we are defining a channel, in this case, just one channel. We call it hello. And then we define an operation on the channel, publish. And then we also define what you can publish, a message with this payload. So in this case, we're just sending a message which has just a string in it to this channel, right? So this is the simplest async API definition you can have. If we look at slightly more complicated one, let's look at this one. So again, yeah, we define our application, and you would have a server to define how to talk to that application. So in this case, it's an AMQP server. And then you would typically have multiple channels. So in this case, we are having two channels. One is a hello channel. The other one is a goodbye channel. And in this case, you can publish to both channels. So you can send messages to these channels. And to the hello channel, you can send a hello message. And to the goodbye one, you say a goodbye message. And then you define what these messages should look like. So here under components, you define your message. So the hello message looks like this. It's an object that has two fields, name and send at. And the name is a string, and send at is defined later. And goodbye has only send at, right? So that's how you can define different messages for different channels. And then if you look at the send at, it's a string, but the format is datetime. So it's a datetime string, basically. Okay. So this is how you kind of define your servers, define your channels, and what goes on those channels in terms of messages. And then once you have this definition, you can use Async Studio, which is a tool to author and visualize these definitions. And actually, if I show you, if I open it here, you will see that it will take a little bit of time to load. You can run this locally as well. So you see I pasted the same definition that I show you, and then you get this nice visualization. It shows you your server. It shows you the operations you can have there, it shows you the payload you can send to that, basically the message. And then you can even see an example here on what kind of messages you can send. And if you have multiple, I think you can see, if you have multiple services, you can see them here. So it's very nice to kind of visualize what you have and communicate with others as well. So that's Async Studio. The other one is AsyncAPI CLI. This is a command line tool to kind of create these AsyncAPI files and validate them. And there's also another project called AsyncAPI Generator. These are code generators for various languages and frameworks. And if you look at these code generators, you will see that on their GitHub, you will see that there's a lot of different generators for different languages, like for Node.js, for Java, for Java Spring, for .NET. But therefore, AsyncAPI is very kind of diverse. You can do a lot of different things with it. But these generators, they work with a small subset of AsyncAPI. So you won't be able to take any AsyncAPI definition and use any of these generators and get code. It's not going to work. You will get some errors. But for small subset of AsyncAPI like AsyncAPI definitions, you might be able to use these templates to get something started and see how you can send and receive messages. So they're very community driven and might not work for all use cases, basically. That's what I'm saying, but it's good to be aware of them and try them out. All right, and now I want to talk about the publish and subscribe semantics in AsyncAPI. These are the two operations that you can have in AsyncAPI, and it can be confusing on which operation to use in what situations, and that's what I want to talk here. And I also want to show you an example so that we can work through this and kind of understand it better. So in AsyncAPI, there's publish and subscribe that you can set on the operation, on the channel as operation. But these mean different things depending on where you're looking from, right? So from the user's perspective, so as a user, I want to talk to the service. Publish means as a user, I'm publishing a message to the service, okay? And then subscribe means as a user, I'm subscribing to that service to receive messages, right? So that makes sense in that, like from the user's perspective. But if you think about it from the server perspective, so from the service's perspective, publish means the service receives the message, and subscribe means the server publishes the message, right? So it's kind of reversed. And then if you are coming from WebSocket world, in WebSocket, publish is more like send, and subscribe is more like receive. So depending on where you're coming from, it can be confusing. And also, these services, they can receive and send messages. So they can, in some cases, they're the user, and in some cases, they're the server, right? So you need to think about from the user's perspective. I think if you stick with this user's perspective and then define your operations that way, then it kind of makes sense. And I actually have an example that I want to show you on this. So let's imagine we have this scenario, very simple, right? We have an account service that publishes a message, user signed up, and it goes to the message broker, and then message broker routes that message to the email, another service called email service. So the email service receives that message, right? So let's imagine you have this. And let's imagine we want to define account service and in AsyncAPI, and we want to define the operation on the account service, the operation on the channel of the account service, right? What should be the operation? Is it a publish operation or is it a subscribe operation? And you might be confused here, but again, let's think about from the user's perspective. As a user, if I want to talk to the account service, what do I need to do? Do I need to publish a message to it, or do I need to subscribe to it? Right? That's the question that you need to ask. And in this case, we need to subscribe to it so that we can receive this message that account service is sending, right? So I think the operation should be subscribe from the user's perspective. So if you look at the account service definition, so again, we define the account service, we define our server, we define our channel, the user signed up, and the operation is subscribe, right? It's subscribe because as a user, I need to subscribe to receive that message. And then here we are defining the message, how it should look like, and all that kind of stuff. Now, if we define email service, now again, what we need to ask, what operation do we need here to talk to email service? As a user, do I need to publish a message to talk to email service, or do I need to subscribe to it to receive messages? And the answer here is we need to publish to email service, right? So because of that, when you look at the email service definition, the operation is publish, okay? So if you think from the user's perspective, then it kind of makes sense. And then one thing you will realize is that my account service and my email service, they have a lot of things in common. Like the servers are the common, the message formats are the same as well. And what you can actually do is that you can create this common.yaml, and you put this common stuff there, like the servers and the messages and the schema of the messages. And then you can define an account service common YAML, and basically instead of repeating everything, can just refer to that. So for service, I'm just referring to what I defined. And for messages, I'm just referring to what I defined. And I just define my operation on the channel. And similarly, with account service common, we can do the same, basically. We just change the operation to publish, okay? And once we have this, what we can do is we can use AsyncAPI CLI. So let's say AsyncAPI CLI to validate our definitions. So make sure that it's a valid definition. So I have some warnings, but there's no errors, so that's okay. And then we can even, we can even generate code from it. So I mentioned there's a lot of templates. So I'm saying here AsyncAPI generate from template, and I point to this Node.js template. Then I point to my email service YAML. And then let's make this a separate folder. And now this will look at the definition, and it will generate a Node.js application that I can use to talk to my, to basically have a server that listens for messages, the email service, basically. And if I go to email service, I will go to the one that I generated before. And then if I do npm start, you will see that it's an MQTT server, so it's waiting. It started on waiting, and then I can use the MQTT to send a message. And if you go back, you will see that it received the message, right? And you can check the code like later if you want. It's a Node.js application with lots of boilerplate kind of code. If you're a Java person, there's also a Spring template you can use. So if we, let me go back here. Let me remove the email service too. But this time, let me generate with Spring template. And now this will do the same, but it will be in Spring. I don't have Java set up on this computer, so that's why it's not going to work. But you can see that it's basically the typical Java stuff that you get. Maybe it's not the best Java code, but it's something that will probably work. You need to try it out. Okay. Okay. All right. So I guess the AsyncAPI, it's a good specification to define which service publishes or subscribe to what events, and more importantly, communicate that with visualizations and with a definition that you can share with people and let people see exactly how they should talk to your services, basically, with what kind of messages and what kind of message formats, right? And then the last thing I want to talk in the last 5 minutes is that, I looked at AsyncAPI, I looked at CloudEvents, and my question was, can I use CloudEvents and AsyncAPI together? Can I have a service, for example, who can receive CloudEvents or can send CloudEvents, and can I document that using AsyncAPI? And the answer is yes. And just to show you this quickly, remember, like in structure mode, we have everything. The cloud event is in the body of the request, right? So if you want to document this in AsyncAPI, all you need to do is you go to your definition of your service, you define your message, and when you define your message in the payload, the body of the message, you add this line, and this line says my body has to have all of this that comes from this cloud event spec. So cloud events, they have this spec, you can refer to it, and with that, your service basically has cloud events enabled in the body. So that's pretty cool. But you might ask, how do I do the binary mode, where the binary mode is just the headers, right? So how do I define these headers? And you can do that as well. In AsyncAPI, there's this notion of traits. So I define this cloud event traits, and these traits are basically message headers that you want to have for your messages. So here I'm defining my own traits, and I'm saying these are the cloud event trait headers that I want. These are the required ones, and these are the optional ones, and I give them their descriptions. And then once you have these traits, then you can go to your AsyncAPI definition. And this time, we define our message, but then in here, not in the body, because this time we don't want the cloud events in the body. We define this traits section and point to my traits. And by doing that, we're basically saying my service needs to have these headers that I defined myself, right? So that's pretty cool. And finally, since I am at Google Cloud, I asked myself, okay, I have Google Cloud. I use Google Cloud PubSub to do messaging in Google Cloud. Can I use Google Cloud PubSub and AsyncAPI together? And again, the answer is yes. I mentioned this before. AsyncAPI has this notion of bindings. And then Google Cloud has PubSub bindings for AsyncAPI. So what you can do is when you define your channels, for example, you can add this binding. And under binding, you have this Google Cloud PubSub binding. And here you can define the Google Cloud PubSub things. So here I'm defining the topic that I'm using. And also if my topic has a schema, then I am defining my schema settings. Or maybe in another channel, I'm defining more things like message retention or message storage policy or the persistent regions. So yeah, so that's possible as well. And it's not just for Google Cloud, but also other vendors like Kafka or I don't know, like any other messaging service you can think of. They probably have some bindings for AsyncAPI that you can use to define it and communicate. So I think it's pretty cool. All right, so that's all I wanted to say. If you want the slides, this is the link. If you want to see more examples, much more than I show you today, this is my repo for cloud events, and this is my repo for AsyncAPI. So feel free to use it. If there's any feedback in the conference, please give me feedback. I'd like to know how you liked or didn't like the talk, and how I can make it better. So please do that. And I think we have 2 minutes. So if you have any questions, I don't know how I would check them, but let me know, and I'll be happy to try to answer. Okay, thanks very much. And let me check. I think
okay.
I was in the chat, right?
Yes, maybe there are some questions in the chat. Otherwise, you can just unmute yourself if you have any questions.
Okay, let's see if there's anything. Yeah, I don't see anything. There's one.
Yeah.
Okay, there's a question. Do you think it makes sense to use cloud events if you're only using Google Cloud PubSub without other message systems? That's a good question. Yeah, and I think we can extend this question to say, if you're using one eventing system, let's say Kafka, does it make sense to use cloud events? Maybe not, because if you're using one message format and you don't anticipate yourself to use any other kind of messaging systems, or you don't anticipate yourself to interface with any other cloud provider for their messaging system, maybe at that point you shouldn't worry about cloud events, really, because if you are in one format, why wrap that format into a cloud event, right? But I guess you never know how things will evolve, right? Like, what if you add a new service in the future, and then that will maybe that will just read events from Google Cloud instead of Kafka, for example. At that point, you will start dealing with two different kind of systems. Do you want to kind of try to standardize them into cloud events so that you can deal with one format at the top level? Probably. So yeah, I mean, it's basically up to you, like, right? Like, I mean, depends on, if it's just one, I would say don't worry about cloud events. But if you anticipate that things will be added in the future, maybe it's good to be aware and to be aware of cloud events, and then try to kind of think about when it's the good time to introduce it, because the complexity of the new technology has to justify you have to justify that somehow as well. So it's up to you when you decide to do that. But yeah, that's a good question. Thanks for asking. All right, I think that's it. So yeah, thanks very much, and feel free to reach out to me on Twitter if you have any more comments or questions. Thank you.